Okay, so ton of questions I want to ask you. But starting with XAI, you've achieved a huge amount with a very small team.
Yeah.
Can you share a little bit about how XAI operates and how you've achieved that?
Yeah. So here's a funny story. When we first started the company, right, that's right after COVID, SF was like coming back to life, and then people were like, okay, maybe we're gonna go from like 0 day of in-office work to like 2 days of in-office work, and we just fundamentally believe that the way you actually achieve make diamonds is put a bunch of raw talent in one single location, you pressure cook them, you make the diamond out of that. So it's like, why don't we just make like, everyone in person, small team, high talent density, densely intense. So that's essentially how we built the company. We shipped Grok 1 with like 12 people back in the days. I still remember like there was like one last feature request from Elon. That was 2 days before shipping, and the whole team didn't sleep for 48 hours, and then we shipped, and that was great. And that was in the basement of the building. And then after Grok 2 was done by a team of 30 people, and then now with Grok 4, the best reasoning models out there on like Arc AGIs and Humanity's Last Exam, Grok Code Fast is like the most used coding models on Open Router. Fundamentally, you actually, once you have like enough talented folks together and all the vectors aligned, you don't really need a huge team to achieve a lot of model training.
Yeah, that's fantastic. Yeah. Can you share anything, other unconventional things you guys do to run the company?
The company is really flat. So you want to have like a very fast iteration loop, like anytime, like, right? Because we talked about how can a small company that's one order of magnitude smaller than any of our competitor. Right now it's like we just shipped Grok 4, 4.1 is coming. Grok 5 is now cooking in the world's largest GB 200 cluster with 100K GB 200s. Like in order to compete, as a small company, if you have fewer people and people working on very different things, then you're not going to achieve the escaping velocity ever. So the only way you can compete as a small guy is to be more nimble and also be more aligned. So a company is a form of collection of vectors. And it doesn't matter how many vectors you have, if they all pointed towards different directions, then you're not going to move very fast. Well, for us is, in order to achieve the vector alignment, well, you should just have like, every time everyone in the company should be able to speak up on like, are we on the right track? Like, here's a new idea. Should we invest resources into it? Should we not? So, and then you just get this like constant broadcasting of like, it's almost like a single collective consciousness of the entire company, like everyone in one Slack channel. Well, literally just one X group chat. So, yeah, for better, for worse. Yeah.
You talked about all the vectors aligning, which makes sense. And you guys have shipped a ton of different products, right? Like Grokopedia recently, yep. Companion bots, image and video gen, Grok, obviously. Like, yep. How is that consistent with your previous statement?
Yeah. So I think fundamentally, when we formed the company is like, hey, why does the world need another AGI company? Well, we think, ultimately, like we want to build AI that's like maximum truth seeking. We have seen other AIs who, behaviorally, they're more controlled, they're more, opinionated on how the AI should behave. I think for us, we're like, hey, what really matters is an AI that's maximally curious, maximally truth-seeking, and we give the controls to developers and how you want this AI. We're not very opinionated on the AI should behave, and you should have the full control of. So that's kind of like the maximum truth-seeking is the fundamental, belief we have is like, well, now then how do we actually make an AI that's maximum truth-seeking? So we talk about this Galileo test internally quite a lot. So what is the
What test did you say?
Galileo test?
Galileo.
Yeah, so what is this Galileo test, right? Just think about, like, today machine learning models, you train to minimize the average loss across the entire internet, right? So then what are you learning? You're learning the majority consensus view, right? That's how you can actually minimize the expected loss. That's what the model is trained for. But if you apply the same loss function to the medieval times, like when Galileos were around, then you're gonna realize that, hey, the consensus that the worlds, the universe revolve around the Earth, right? So which is not true. But instead, well, you can have to like comb through the noise, and then you're gonna make experiments, you craft your own tools, and start making measurements. You're like, oh, wait a second, it's like like have to reason from the first principle. Be like, hey, that maybe the consensus is not quite right, right? So that's kind of the Northern Star we're striving for.
That's actually conceptually makes a lot of sense. Do you have good evals for that, or is it more of a conceptual thing?
Yeah, so Grokpedia is one step towards that, where there's like, hey, how can we actually apply a lot of reasoning to a collection of knowledge on the internet that's already accepted as common wisdom? Can we go through every single primary source and thinking from the first principle and question every secondary sources you get? And are there any new summaries we can get out of the wealth of the data on the internet? Because oftentimes you can look at the majority of the data is actually a second-hand, third-hand rewrites of the primary source, right? That's no different than today in our LLM training. It's not like that we train a model to like steal the book like Harry Potter or anything, but just like there's so many rewrites of the same corpus on the internet, and the conventional deduplication is not able to remove that effectively. So then we just fundamentally have to rethink about in pre-training, like instead of doing deduplication, what if we just rewrite the entire data set and then to make the maximum truth for training set for the AI? So that's kind of one step towards that. And in the XAI culture, getting the very fast feedback loop is crucial and essential. So we kind of put ourselves out there, be like, hey, like.
What's the feedback been?
Well, I mean, you can imagine like there's like the best feedback you can get is like, you want to have this like community notes, right? That's like where you have statements out there, you have like the folks, instead of having a dictatorial editorial view on how that article should be written, everyone should just come in together as just put in the community notes, and then AI can be the moderator. Like Grok can be like the best moderators. Be like, hey, Grok, fact check this.
That'd be awesome.
Yeah.
Can you share a little bit about your enterprise efforts?
Yeah. So some of the problems that we thinking about training our model is that if you think about like how the language models evolved in the last 3 or 4 years, the chat assistant is a primary application of these language models. The majority of the applications for chat assistant these days are question answers, especially in education. You ask questions about calculus, how to solve your homeworks. When I was teaching back in the days in 2023, it was very obvious that who's using the models to answer the question, who's not. But over time, the models, the Grok 1 we had in 2023 was almost just a high school student, intelligence, can barely answer any of the MATH, which is a data set, which is a bunch of high school math, competition math problems. And now today we have Grok 4 that actually can able to solve some of the reasoning tasks in grad school that most of humans probably will not be able to do that on average. So the intelligence of models has exploded, right, from high school students to a very competent grad students. But the problems that most of the chat assistant users are asking is still the same. Hey, how can I solve this? How do I linear algebra problem? How do I help me to write this essay, right? So you're always asking, why do we actually start building more and more intelligent models? And I think the answer here is that because we want to use these models at XAI to solve some of the hardest problems like the entire humanity has ever faced. So what are some hardest problems? Well, the hardest problem are putting men on Mars, in a totally different planet, millions of robots, clean energy, pharmaceutical advances, accelerating scientific discoveries in material science. These are actually the hardest problems we're facing as a humanity. And that's where having these intelligent models, automated business flows, not just from automation, but to optimization, is really going to accelerate the scientific progress. That's fundamentally how we think about our enterprise effort.
Okay, that's awesome. Let's talk a little bit about research. So you've been working in AI research for at least a decade.
Sure.
What are your thoughts on looking back how AI research has changed during that period?
Yeah, I guess you and me, we met each other a decade ago, literally in a place called Machine Learning Deep Learning Summer School.
Yeah, UCLA, I think.
UCLA, and I remember Elias Discovers was there, Wojciech was there, and then we were young bucks learning about, oh wow, there's dropout and there's neural nets, ReLUs, and that was and then Jan LeCun was talking about his sparse neural nets. Yeah, you hear, oh, those are great ideas, and then you can't wait, just go home and try it out. And that's my very fond memory was I heard dropout, and then on the same night I went back to the dorm. We all live in the UCLA dorm, and then I just coded up and it worked. I was great, amazing. But I think if you look through the last decade, you have a 4 years of discovery phase where most core ideas today we're facing is transformers, atom optimizers, batch and layer normalization. These core and diffusions, energy-based models, these are core ideas all being discovered right after the summer school. And then there's the phase of hey, you take that engineering to the next level, so you can actually start training models from 1 GPUs to 8 GPUs, or even orchestrating a few of the RL ideas. That was also the large-scale engineering challenge where you see AlphaZero, where you see the Doda project came out of OpenAI, and I think Ray was actually fundamental to a lot of these progresses at that phase. And then you have the last phase, which is balls to the wall. You get 100,000 GPUs coherently training on a single workload, right? So I think my hot take on what happened in the machine learning field is I don't think we have progressed on the research at all in the last 80 years. So most of the core ideas already been there, and it's just a matter of having a very strong team that be able to try to combine the permutation of all these ideas that's already been discovered, and teams that be able to run faster than the other teams, oftentimes able to pick the right fork in the tech tree to go down.
So are you saying not only have we not made progress in research in the last 10 years, are you saying do we need new progress now or in research, or is it more engineering?
So internally at XAI, the word research is actually banned. So ironically as it is, I'm been doing research for a while, and because fundamentally we think about the problem as it's when you build Apollo project, right? You know the direction where you're going to go. You know the distance, about 400,000 miles, and you just build it and go. And then you shoot a rocket, land it on the moon, and come back safely. Yes, there's a lot of innovations you have to do along the way, but it's very much an engineering challenge. And we're going to have even more engineering challenges of today at XAI, we just stood up our Colossus 2, world's largest GB200 cluster with 100K GB200 training coherently. We showed that in live stream 2 months ago. We scaled RL workloads to the same scale as pre-training to train our Grok 4. All these are algorithmically very simple ideas, but it's almost some of the hardest problems in engineering, right? So the reason why, well, we're actually training on 8 GPUs on a single node. Some GPUs flicks, that's fine, but when you actually have so many different GPUs, right, it's just a Poisson distribution, something gonna go wrong. And then it's just a matter of time, right? You're waiting for that bus to come to hit one of your GPUs, and that bus is one of the cosmic rays that beams down into a transistor. That bit get flipped, and sometimes you get lucky. You're not flipping, it's only in the lower significant digit. digits. Sometimes you get unlucky, you flip a Mantis a bit, and then now you like all of a sudden your gradient explodes, and then you don't know why, and then now you have to have like all those health check mechanism to making sure like I'm actually able to like categorize different mistakes, and the mistakes across different hardware classes like the Hopper generations to today the Blackwell generations. The health check system is actually very different we're building because we're seeing a very different errors you're going to get when you're actually training at a large scale. So yeah, these are just very boring, mundane problems you have to solve from a research perspective, but it's extremely challenging and it's probably the hardest engineering problems we ever face.
Yeah. I mean, this is an infrastructure audience, a lot of people here. You probably face a lot of these types of infrastructure challenges that maybe no other companies are facing. Can you share more about what those kinds of challenges are?
Yeah, so I think reliability, like getting right. So fundamentally, there's the problem. There's in computer science, there's two problems. Like you build. The problem number one is like how do you build a computer, right? So XAI is the only like AGI companies that actually builds our own computer, like we build our data centers. And then so there's many innovations you have to think about actually building the data centers. Like do I actually need like 24/7 uptime, right? Can I run faster by rethinking from the first principle? How is the cooling and thermals and the network topologies can be done in a way that I can bring up the data center faster, right? Because I think at this point, like any startup would rather trade 2 or 3 months of your time for like for anything. But it turned out not only you're able to build faster, but also you can build cheaper. So now once you've actually built a computer, what do you do? So now because then you kind of actually have to vertically integrate your training frameworks, the infrastructure. You have to orchestrate the workloads. We're moving away from the homogeneous, a single workload. You compute the gradients, shard it across many nodes, and then you aggregate the gradient to all reduce and all gather, to a world where now you actually have heterogeneous workloads where you have some nodes doing inference and some nodes doing the back propagations, and then sometimes today, right, the Grok 4 class models, they're able to like coherently go out and do things with 2 million contact links on the task of 30 minutes to 2 hours ish if you provide a scratch pad to these models. Now. The next generation models we're going to have will be able to think coherently and solving a task from 2 hours to 8 hours long, right? So now you have this strangler problem of like if you do reinforcement learning. So are you actually going to wait for the time between 2 hours and 8 hours, right? And not making any grading updates, right? Or you're going to have to figure out a more clever solutions that you can let all those chips doing inference maybe asynchronously, and some other chips doing grading updates and weight updates asynchronously, and then you would figure out how to broadcast the weights across all the nodes.
There's growing heterogeneity and growing, lots of different dimensions of scaling there.
Yes.
You talked about infra challenges for running on hundreds of thousands of GPUs. If you had 1,000 times more GPUs, say hundreds of millions of GPUs, what would you do with them?
Oh, easy, right? So you just you take some of those nodes just as like, so internally we always question like how far can we scale these problems, right?
What's the answer?
Turned out it's like very far. Like you always want, I think we went through this realization earlier in the field. We're like, hey, we gotta be chinchilla optimal, right? Like we gotta utilize every single bit of compute that optimally to train the best model that compress the tokens well, right? That's what instantial chinchilla tells you, that exactly how to trade your compute on the model size versus how many steps you train with the number of training examples. But that's only for training, right? So, and that was a very myopic view of how we should think about scaling compute for AIs. Why? Because if you like today, right, company like Together, company there's tons of inference companies, the Fireworks, including ourselves, we're serving hundreds of millions of users. So majority of compute, you're gonna spend is actually in the inference time, right? And same with the reinforcement learning. Like majority of computers actually generate those entire data. And as these models are able to solve tasks from 2 hours to 8 hours ahead, the time you're going to spend doing inference is only going to grow exponentially more. So because like, why would I, like, if I can have, right, like, people ask, hey, what if I make my algorithm like 10x more efficient? Do I still need more compute? Well, the answer is, why wouldn't you? Yeah, sure, you can have a model that's equal intelligence with 10x less resources, but why wouldn't you want to have a model that's like 10x more intelligent if you had access to more compute?
Yeah. Now, you mentioned generating data with reinforcement learning. Like right now, all the frontier companies spend a lot of money on human-labeled data, right? And the trajectory here over time has been to start with like relatively simple labels and to get more and more expert-crafted data. And not just expert-labeled data, but also expert like crafted RL environments and things like that. So how far can we take that? Are we reaching the limits of the kind of data we're going to be able to buy?
Yeah, absolutely. We are, unfortunately, it takes 18 years to grow a meat computer to be able to generate useful tokens. Where we went from Grok 1 to Grok 4 in the span of like 29 months. We are hitting a cognitive, like we call it cognitive, like a blocker on the cognitive supply chain, where internally we actually have our own AI tutor teams. Where we started this team, 3 months after we started the company, because we realized that hey, like having a very quick feedback loop internally to actually post-train our models is crucial. And recently we just started re-examine the assumption of like. What kind of knowledge are actually most useful to train these models? And it turned out like models are actually on average much better at writing very simple essays and doing summarizations better than most of the humans, right? And if you give the right context and prompt them correctly, and they can be great co-pilot. And what you really want are those like domain experts. Mm-hmm. And eventually we're going to run towards a world where it's probably going to be a zero sum in actually getting the best AI tutors and the experts to train Grok, where there's only one Terence Tao, in the universe, and you want to get the best tutors, right? Just think about if you're parents, right? Why wouldn't your kids to receive the best education and best feedback loop? So now, how do we actually overcome this, the blocker on the cognitive supply chain? Self-play, self-improvement loop is essential. So I think many people often ask, hey, why does it even make sense to actually train AI models to generate its own data and gets really good at what it does, and then actually even go beyond the teacher model that you generate data from? Well, the answer to that is an analogy of our human society, right? So if you think about the entire human trajectory, the hardware, the neural nets we're running are not that different across the last probably million years. And yet, we seemingly behaving like information perpetual engine. Like we're consistently able to come with new innovations. We went from hunter-gathering societies and now be able to build this marvelous city and be able to actually start building AIs to start automating our work, right? And all these are, actually.
What other analogies from human society do you think are relevant for the progress we're going to see in AI in the coming years?
Yeah, multi-agent systems. I think most of these self-improvement loops are probably not going to happen if you just have one hunter living at one location, right? But a lot of that come from you start forming a village, and the village compete with other villages, and other villages can start forming cooperations and forming a county, and gradually. So I think if you really want to kick off this self-improvement loop, where the AIs can actually start go out and make discoveries by itself and gather training data, train the next version of itself, and take those training data and compress them into the codex and textbooks that you read for the next generation of AIs. You actually need this multi-agent systems where you can form this competition dynamics. So.
Can you share anything about what you're excited for the next couple of years? or with AI in general?
Robots. Yeah, so I think Chelsea was here earlier. I think I really resonate with her takes. Today everyone's asking, hey, when are we going to have like 1 gigawatt compute? Well, Anyscale, we almost have 1 gigawatt compute, the coherence for trading.
You're going to have more compute because you build it in-house, is that?
Yeah, the speed is, is crucial. But I think the real question is when are we going to have 1 million robot, coming on the road and doing trolls for you and start moving atoms. And I think we're on this we often make analogy of like, hey, like maybe this is gonna play out this very similarly like self-driving. Like my personal view is like it's probably going to be a lot more accelerated. There's a lot of learnings and winding paths we went down in the self-driving world the last like 6-7 years. But also we learned a lot of lessons. Having real-world feedback loop is essential. Be able to like collect data at a massive scale is essential. So we can take all these learnings and actually accelerate this like robot world. And then you're probably going to have like, I don't know, the future is going to be crazy. In the next 2 or 3 years, you're going to have millions of robots. And
what are they going to do?
Well, I mean, we're going from like fundamentally in economy, right? Talk about enterprises.
Yeah.
It's like the majority of there's like a large chunk of global economy. It's just achieved by moving bits around.
Yeah.
But eventually, to actually have a true 10x scale of the global economy, you need to move atoms around, right? And then supply chains, manufacturings, and getting those robots to solve some of the the hardest problems, like stand up a foundry, right? That's probably the hardest engineering problems you have in the real world, other than like putting men on a different planet. Yeah.
And then how do you see the role of what are people going to spend their time on in this world?
Well, that's going to be a tough one. Well, what is human going to do? Well, that's why we shipped Companion, right?
Yeah. Okay, Jimmy, thank you so much. It's been a pleasure. Yeah. Really appreciate all of your insights. Please join me in thanking Jimmy. Yeah. Hey, thank you.
Yeah, great.
All right.